First of all, it's both very elegant and very simple at the same time. So it's simple to apply and simple to use. It's literally 4 sensors that you place on the chest surrounding the heart and the great vessels. You want to create an electrical field around the chest. What we do with those sensors is we instill a very small high-frequency electrical current, and then we watch as that current comes back to the sensors, and we look at the changes in those currents. So we're creating this electrical field and looking at the changes. It's a little bit similar to ultrasound in that if you think about ultrasound, you apply ultrasound waves, watch them bounce back, and see how they change as they come back. Same sort of principle, only with electrical activity. And so that electrical activity changes in a couple of ways. It changes both in the amplitude, the height of the waveform will change a little bit, and then the timing of that wave changes. Our special sauce is in the timing of that wave, because that's where we look. And the main thing that causes a difference in the timing is the amount of red cells, the amount of blood volume in that box.
Okay.
So if you think about it with the cardiac cycle, the main thing that's changing in here during the cardiac cycle, which is where we're looking, is between systole and diastole, there's different blood volume in the chest. That, of course, the volume leaving the box would be the stroke volume.
Okay.
So we take that electrical signal, and we have looked in over 65,000 patient samples and correlated that to very well-executed, tightly controlled thermodilution to arrive at stroke volume.
Okay.
That's how we do it. And so, in essence, we're looking at the electrical signal change that is correlated to the blood volume that leaves the chest with each heartbeat, which, of course, is stroke volume. One of the core advantages of using this technology is that it's very easy to use. So literally by placing sensors on the chest, you can hook up and have a cardiac output within minutes. The other thing I think that is a core advantage of this too is we measure centrally. So we're looking at the blood volume leaving the chest directly at the chest. We're not looking at arterial waveforms peripherally or other things that can be distorted from the chest out to wherever it is that you're measuring. So we measure centrally. The nice thing about bioreactants is that those limitations don't exist. We measure centrally, so we're not impacted by vascular resistance changes or changes in an arterial line. We aren't impacted by respiratory changes. We're not impacted by dysrhythmias. So all of those things, our technology is very robust and has the ability to play through all of those.